Okay, this is the video lecture for Math 181 for Tuesday, April 21st. And the topic for today is the substitution rule. And the idea behind this is a technique we can use to evaluate integrals. Now, if I gave you guys the indefinite integral x to the n dx, or the indefinite integral sine of x dx, you guys could do these indefinite integrals. That is, you could find the antiderivatives of these functions with the techniques we've already learned. In fact, these are in the table I showed you guys in the last video. By the way, this is part one of the video lecture for Tuesday, April 21st. I'll do a part two as well. So we can do these integrals. But what if I gave you an integral that looked like this? How do I find the antiderivative of that integral? This is a lot tougher. I don't know, it's not obvious to me how to find a function such that the derivative of that function equals this function. Okay, but fortunately there's a technique called the substitution rule, and that allows us to evaluate this integral. And what we do, the way this works is we introduce a variable. So we let the variable u, sorry about that, u equal x squared. So we're going to introduce this variable u equals x squared. And then what I do is I take the derivative of both sides of this equation. So I get du dx. And now I take the derivative of x squared with respect to x, which gives me 2x. And then I rearrange this equation. And with a little bit of algebra, if I move things around, I get x dx equals du over 2. Okay. And now what I do is I substitute what I've learned here back into this integral. I'm going to rewrite this integral. I'm just going to rearrange this. So I have x squared x dx. And now notice I have this part in terms of u. And now I'm going to plug in u for x squared. And so now I'm going to substitute in for u. So now I get e to the u. I get e to the u, and then this part here, x dx, is du over 2. Okay. And then what I do is I can pull out this constant 1/2. So this equals 1/2 times e to the u du. Okay. And now the good news is I've taken an integral I didn't know how to do, and I've converted it into an integral that is very easy to do in terms of the variable u. And as you guys all know, the integral of e to the x or e to the u, doesn't matter what variable it is, or e to the elephant, is always going to be e to the u or e to the x here. So if I now take the integral of this, I get e to the u, right? The integral of e to the u du, or the integral of e to the x dx, is just e to the x. Plus I have to add my integration constant c. Okay. And then the final step here is, because my integral was originally in the form of x, I want to substitute back in turn it back into an x equation, not a u equation. Well, u equals x squared, so this integral then equals 1/2 e to the x squared plus c. Okay, and the c is the integration constant. And so this is the answer. This is the integral. This is the integral of x e to the x squared dx. How do we know this is correct? Well, we can take the derivative of this. So if we take the derivative of 1/2 e to the x squared plus c, let's take the derivative of that. The first part here, we get a 1/2. Then we get derivative of this function. Derivative of e to the elephant is simply e to the elephant, okay, times the derivative of elephant with respect to x by the chain rule. The derivative of x squared is just 2x, okay? The derivative of a constant c is 0. And so now we have this, and then this 1/2 and 2 cancel out, and I get back ex squared. Well, guess what? This is just what I had. This is called the integrand, by the way. The integrand, the function under the integral sign. I get back what I originally had under the integral, so this in fact is the correct antiderivative of this function. This is the answer. We basically use this clever technique of u substitution, or the substitution rule, to evaluate this integral. And more generally, you can use the u substitution technique if you have an integral of this form, and don't worry too, this is sort of more of the abstract theory behind this. Don't get too hung up on this. But you can basically use the U substitution technique to evaluate an integral if you have an integral that's of this form, where you have f of some function of g of x times g prime of x times the derivative of this inside function with respect to x times dx. In this case, we had that because our f here, so in this case, our f was e to the something, and our g of x was x squared, okay? And then we had an x dx. If you take the derivative g prime of x, you get 2x dx. And so this part here, you get 2x. So we had an integral of this form, which allows us to use the U substitution or substitution rule technique. Now, one note to you guys, using the substitution rule is a bit of an art form. So it's not always obvious what to let U equal in these integrals. And you get better at it by doing more of these problems. So the more problems you do, the better you get at knowing what to let U equal to evaluate these types of integrals. Another note to you guys, not all integrals can be evaluated using the substitution rule, okay? In fact, there's a whole bunch of integrals that you can't use the U substitution rule to evaluate. So we have to have a kind of a special situation to use the U substitution rule. We had that special situation here. So if you ever try to do the substitution rule and you can't do an integral, it's likely that you have an integral you simply can't use the U substitution rule for. And there's other techniques of integration we can use to do those. Okay, that concludes part 1 of this video.